Okay friends, welcome to part 3 of our video presentation on big data. In part 3 we'll continue talking about various technologies that typically comprise the big data IT infrastructure. Now, next technology that we will discuss are the so-called non-relational or NoSQL databases. A bit of history. Since 1970s, database management systems have been had been dominated by relational databases. In this class we did some ERD modeling, so this is the essence of relational databases. Data is stored in rows and columns, where rows represent instances of an entity. Again, going back to our ERD model exercise, that's what we did. Columns, they represent attributes of entities. And then there are relationships between those entities implemented with the help of primary and foreign keys. So that's why those are called relational databases. And then once you create a model of a relational database, once you build a database based on that model, data can be accessed using SQL queries or SQL language. Now, non-relational databases, they're relatively new, and they take a slightly different, if not orthogonal approach to storing data. NoSQL databases or non-relational databases, they store any type of data structure. So data does not have to be broken down into rows and columns with relationships being specified. So whatever is found can be stored in a NoSQL database. And then you don't need to use SQL to retrieve data. Although NoSQL databases, they can use SQL. So strictly speaking, NoSQL term is a bit misleading, because SQL is used, can be used as a part of a non-relational database management system. Some examples of what non-relational or NoSQL databases are good at storing would be like files, like XML data, text files, audio files, video files, images, and also application-specific document files. So basically, those files are stored as is without breaking those files down somehow into rows and columns, and without specifying relationships. And then you have this key value pairs, so you can retrieve individual documents by using a key. Some widely used open source NoSQL databases, I think it's a spelling error, it should be like that, contain Apache, Cassandra, MongoDB, and Apache Couchbase. I would say the first two are commonly used nowadays. Okay, next we're going to talk about Hadoop and MapReduce. Now, Hadoop and MapReduce pair is often synonymous with big data. So a lot of the time when people say big data, they assume the big data initiative that they're talking about is based on Hadoop and MapReduce. So Hadoop and MapReduce are two technologies that are essential to big data movement. Origins of these technologies trace back to early 2000, when internet companies such as Google, Yahoo, and Facebook needed ability to store and analyze massive amounts of data from the internet, from their users, from their interactions with their websites, and this data kept growing, so they had to do something about storage. Now, first we'll talk about Hadoop. Hadoop is a software framework. Okay, so it's a software framework. It's a software. And it's distributed by an organization called Apache, I believe. That's the name of the organization. Now, Apache is not a for-profit company. It's more like a foundation for distributing certain open source software. One thing that Apache is famous for is their Linux-based web server. So they also distribute Hadoop. Now, Hadoop is a software framework for processing large amounts of data across potentially massively parallel clusters of servers. So, for example, Yahoo has 42,000 servers in its Hadoop installation. Once again, Hadoop is open source, and it can be downloaded from the Apache website. Now, the key component of Hadoop framework is the Hadoop Distributed File System, or HDFS. Now, this file system can manage large data, big data spread across several servers. So advantages of this file system include the following. Servers can be managed in parallel, so you can build those massive grids that have the same kind of computing power as supercomputers. It's file-based, so it does not need to have any data model, so you just store data one file at a time, and those files can accommodate any type of data structure. So Hadoop is a framework that allows to handle massive data sets with the help of its own internal file system. Now, MapReduce is an algorithm. It's an algorithm that is used typically as a part of Hadoop implementation, so specific algorithm for storing data. The essence of MapReduce is that it takes large data sets, extracts and transforms useful data, and then distributes the data to various servers where processing occurs. And then results can be assembled back into smaller, easy to analyze file. Now, MapReduce does not perform any analytics. It just provides frameworks that controls the programs, and those programs that are based on Hadoop framework are often written in Java. And then those Java-based programs, they're the ones who perform analytics. So MapReduce is like a background infrastructural technology. Now, Hadoop can be used without MapReduce and vice versa. So basically, Hadoop is a framework within which MapReduce algorithm for data management is implemented. Now, this is how MapReduce algorithm looks like. First, you have input. You have some data coming in. So in our case, it's just like a collection of words. Now, this input is split into several chunks, and each of those chunks is redirected to a particular server that can process one chunk. Now, the first thing that servers do, they try to map this data. Map means they try to find some patterns. So here, from this chunk of data, the following map or pattern is discovered. That deer is mentioned once, bear is mentioned once, river is mentioned once. And then in this chunk of data, you have the following map. And then those maps, they're matched together or compared side by side, and this is called shuffling. Okay. Now, once shuffling is done, the data is reduced. Instead of mentioning car 3 times, you have car 3, right? Instead of mentioning deer 2 times, you have deer 2. And then the final result is stored in a file, and the file will have a content that looks like this. Now, this algorithm, if you think about it, is kind of similar to archiving. This is how archiving is done, how files are compressed. And the intent here is the same thing, to distribute the processing over several servers, and at the end of the day, to compress that file. And once you want to decompress it, you can easily decompress, find the actual content of those files across several servers. A few words about platform integration. Now, big data is still is still a new movement within organizations. Therefore, there's no single platform for implementing big data. So a lot of organizations, they have this kind of patchy architecture that contains many components. For example, you may have machine data that is analyzed by a streaming CEP engine, and then it's parsed into a data warehouse. Then data warehouse is also fed with operational data from existing ERP system. Perhaps existing operational storage can be managed using Hadoop clusters. And Hadoop clusters also store information from external sources like web data, external audio, video data, and so forth. So it's all parsed into a data warehouse. Then you have virtual sandboxes. You have standalone analytical sandboxes, that are like actually separate servers. And then you have power users who work with those sandboxes or directly with the data warehouse. And then you have a casual user, meaning like a non-analytical user who just retrieves reports from a particular BI server. So he uses like a specific BI application that is linked to the data warehouse. So what I'm trying to illustrate here is that nowadays organizations, they integrate various components of big data into one information system. So there's no like standard platform, standard solution for all big data needs. Some popular analytical tools, SAS is very big in data analytics in general, but especially with respect to big data. SPSS is SPSS Modeler is a well-known software that is used in business and social sciences. A few years ago, it was purchased by IBM. R is an emerging standard in several industries. R is a programming language, and some experts predict that R will quickly become the de facto language of data science, data analysis. One good thing about R is that it's open source and there's a library for pretty much anything. Regardless of what you want to do with data, be it text mining or web mining or anything else, chances are very high that you will find a library written for that. And then don't discount Excel. I mean, Excel is still a very powerful tool. It's been around for decades. And a lot of vendors of sophisticated big data analytical tools, they still provide some sort of Excel-based interface. For example, I know for sure that SPSS can, read Excel files. R can be integrated with Excel, where data is read and parsed into Excel. And Excel itself, I mean, there are just so many plugins distributed by different vendors that can do sentiment analysis, statistical analysis. All kinds of tools can be, added to Excel to do analytics. But I think one feature of Excel, that is widely used by analytical applications, that Excel is a very common interface between users and organizational data. So a lot of people have been using Excel for many years. They're familiar with the interface. So that's why a lot of BI or big data vendors, they still try to make sure there's capability, there's a feature that allows import and export or even real-time access with the help of Excel. At the end, I will make a few comments about big data and privacy. Now, privacy can be the issue of privacy in relation to data can be summarized with the following question. What data should the government and other organizations be allowed to collect, and what safeguards should be in place about how this data is used? So this is the essence of all debates concerning privacy. Now, big data attenuates, big data makes privacy concerns much stronger, because before big data, the concern was that there is certain data that is available about certain individuals, and certain proportion of the data is sensitive or confidential. Well, with big data, you can say that nowadays all data is available about all individuals. So the number of the proportion of sensitive or the chance that sensitive information can be found or revealed is growing exponentially. So basically, big data makes privacy concerns much stronger. Now, privacy is something that is definitely first of all, consumers, individuals, they may benefit from big data applications, as consumers of private for-profit companies. Also, when government or public services companies, they use big data, they can also create a number of useful services. However, no matter what they do, there's always that side effect where some people are not careful about using data that is available about people, or they're intentionally trying to compromise somebody's privacy. So unfortunately, there is something that is there, and in case of big data, privacy concerns are even stronger. So even more work on the technical and behavioral side needs to be done to prevent companies from misusing certain confidential, sensitive data about consumers. So that concludes part 3 of our video presentation on big data. Thank you for listening.